Welcome to EPG Pathshala. I'm Dr. Lalita Murthy from the University of York. Today I'm going to be talking about spoken word recognition. Spoken word recognition. In this unit, I'm going to be talking about how we perceive speech. So a key stage in speech perception as we are listening to anybody speak is identifying the actual words that the speaker is saying. And in order to understand the meaning of the words, we first need to recognize the words. And a very important aspect of speech is that speech is transitory. Speech is not, it has a definite beginning and a definite end. And once speech is articulated, it's gone. So what it means for the listener is that they have to get what the speaker is saying while the speaker is saying it. And this sounds very complicated, yet listeners are very successful in hearing, and usually they don't have any problems in hearing. So how is it that we are so successful as listeners? So in the next slide, we're going to be looking at some aspects of speech itself. The first aspect, as I said, is that speech is transient. Speech has a beginning and an end, and once it ends, it cannot be brought back. And this means that we need to process speech very quickly before it ends. And in fact, we are able to do that because we can process phonemes at the rate of 20 to 30 phonemes per second. So how are we able to do that? Let's have a look at how we are able to do that. And that's what this module is about. So here are some of the aims of this module that we're going to look at today. First, we need to consider the nature and the properties of speech. The first thing I'm going to look at is the nature and the properties of speech and how that influences listening. The next thing we'll be looking at is the processes and the actual stages at which the recognition takes place. And then lastly, we're going to look at two very important models of speech recognition. These are the three things that I will be looking at in this module today in this session. So let's look at the properties of speech. One of the most important properties of speech is, of course, as we said earlier, is transience. Speech is transient. You cannot bring it back once it's gone. But then there are other aspects of speech that are very important as far as listening is concerned. One is invariance. This is a very important property of speech. Speech sounds are not articulated exactly the same way each time they are said. The same phoneme is maybe articulated differently by the same speaker on different occasions. And it also depends on what follows and what comes before the actual sound. So there is no fixed acoustic form of sound. There's no one fixed acoustic property that we can say that belongs to any sound. So, and this leads to the problem of what we call invariance. So let's look at two words as an example. Let's look at the words which you will see on the screen, heed and hood. I'm now going to say them and just listen very carefully to how I say them. So I say heed and the other word is hood. Heed, hood. Now, how do we recognize? Do you notice that the ha in heed, my lips are slightly spread? But the ha in hood, my lips are slightly rounded. Say them yourself and you will feel the difference. You can say this with any sound in your own language. It's just that you need to change the vowel after the sound. And you will notice that the lip has changed. The whole sound, the acoustics of the sound has changed. And yet, we know that the ha in heed is the same as the ha in hood. How do we do that? We do that because of what we call categorical perception. Now, all aspects of categorical perception are covered in module 6 of this course, which you will, if you want, you can refer back to the material and to the lecture that precedes this one. So I will not be covering that in great detail, except to say that as listeners, we recognize the sound h as being the same h irrespective of where it is articulated, what sounds follow it, and who speaks it, and in which context. So this is an important thing. If we do not have an acoustic representation of a sound, how is it that we're able to do that? And this is an important aspect. So let's move on to another important property of speech, which is what is called co-articulation. Co-articulation sometimes is also known as context dependence. Now, as you are listening to me speak, you might observe that the sounds that I'm making in the words that I'm speaking are blurring one into the other. There's no clear point at which you can say, I have said this sound and then the next sound follows. So the sounds blend into one another. They sort of run into one another. And thus we say that a particular sound is highly influenced by what comes before it and what comes after it. And this results in the particular, in what we call substantial co-articulation. That is, bits of two sounds coming together and influencing each other. So let's look at some examples. And as you will see in the material, look at the words as you will see on the screen. The words spelled Football. If I said it the way it's spelled, I would say it as football. But I would not do that. In fast speech, I would say football. What has happened with football? The last sound of foot, t, is a voiceless sound. It doesn't have any voicing. And the first sound of ball, b, is a voice sound. Now, the voicelessness from the t influences the voicing of b, and b loses its voicing, so it becomes p. And it sounds like football, where you don't really hear it as football, but you hear it as football, and the t is the devoicing spreads to b. Another example is cost price. When you say cost price at fast speech, what's happening is that you're losing the t and the p become blurred into p. You don't hear the t distinctly. Look at churches. You hear the last sound as z, but it's spelled as s. Why is that? That churches is being influenced by the ch, the sound that comes before the z sound at the end. So this is what we call co-articulation, where sounds blend into one another. So does that mean, do we recognize a word phoneme by phoneme? Not really. We do not recognize words phoneme by phoneme. That's the simple answer to that. So let's look at the processes of listening. We've looked at two important features of speech. One is invariance, one is co-articulation, and one is the fact that speech is transient. Now, how does listening occur given that speech has these features that influence the way we listen? The basic process of listening involves two things. First, it involves breaking the speech signal into its component parts by matching the acoustic properties in the signal to the representation of these linguistic forms in the mental lexicon. Now, there's a lot that's packed into this. I'm going to just very quickly unpack it so you know what I'm talking about. Firstly, so what I'm saying is that as we are listening, the speech signal hits our ears, and we are able, our mental lexicon, our mental systems are able to break up the incoming speech signal into its component bits and then to match it with the representations that we have of that word in our brains. So this implies that firstly, there is a mental lexicon that we all have inside our heads where all the words that we know of any language that we know are stored. And these are the acoustic representations of the words that we hear. Now, how are words really represented in the mental lexicon there's a big controversy about that. There are many arguments about what the nature of these actual representation is. We're not going to look into that, and that issue has in fact not been really resolved. It depends on the model of speech perception that you're following, that you will consider the particular representation depending on which model of speech perception that you follow. So we don't really even need to go into that. All we need to know is that there is a mental lexicon where the acoustic representations of words are stored, and there is speech, where you hear the speech signal, And somehow the speech signal is mapped onto these representations. Now, repeated studies have shown that when the speech signal tries to map onto the mental lexicon, to the representation in the mental lexicon, as the speech signal hits our ears, a number of possible candidates are activated. Why does this happen? This happens because as words contain words within each other. So if I said the word card, it really consists of two words. It can consist of car and then card. So by the time you hear car, there is a possibility the word will end at R, which is C-A-R, car, as the one that you drive on the roads. Or it could become card, which is, a card, like a birthday card or something like that. Now, it depends how much of the speech signal there is, because if the word is car, then there's no more after that. But if you hear something else following, and you should be able to hear it, because in Unit 6, we have talked about, how acoustic cues are already present in the preceding sounds. You are already aware there's something else following this card, and that's where the word ends. Now, card could also be for a further part of a word like cardinal. So you see the words, they're words within words within words. But until you hear the full signal, until you come to a point, you don't know what it is. So therefore, given that, as soon as we hear the acoustic signal hits our ears, there are a number of possible candidates that come up. And we'll see how the listening goes on based on these two important factors. So one is there's a speech signal, which as we break it up into its component parts, and as we recognize the component parts, we map it onto the representations in the mental lexicon. That's where we are so far as the basic process of listening is concerned. Okay? And word recognition happens incrementally. Just as I said, when you hear the word card, you hear ka, a, and d. These are the three sounds, so they hear one by one as you hear more and more and more and more. As the signal unfolds, there is more and more input available to the linguistic system, and words become easier to recognize. So there's more of the input, the easier it is to recognize. In fact, listeners recognize a word long before it finishes. So you can recognize that card is coming to an end by the time you almost come to car. It's there. The acoustic cues are already present in the signal. So let's look at speech segmentation. Say the sentence aloud and try to identify where each word begins and where each one ends. I'm going to read it out now once, and you can take time and read it for yourselves. They left for New York last week. And you notice that I do not say they left for New York last week. We do not speak like that in real life. If we did, nobody would want to talk to us forever. We would never have any friends. We speak fast, and yet our listeners get what we are saying. So we don't recognize each word as it occurs. But then we are able to make out each word as a unit by itself, and that is the segmentation problem. How do we know where to segment the speech input, the speech signal that we hear? So let's take an example. Let's say you hear the sound k. Now, upon hearing k, there are a whole host of possibilities that can come up. So let's consider some of the possibilities. You can imagine the word could be cat, car, card, cart, castle, cattle, cool, kill, king, court, cave. Now, I'm doing this with English, but this is the same with any language in the world. So it might be a useful exercise for yourselves to try it out. Think of the word sound k, and think of the possible words that could occur with the sound k in your own language, if there is a sound k. Yeah. Now, there's an infinite number of possibilities. All I have given you is a very tiny, teeny number. But let's see. So you hear k, and the next thing that comes in the signal is e. So you hear k. Immediately, a whole host of possibilities are ruled out. You know it can't be car or card or card. It has to be ki, something that starts like kill or king, or, kim, kith, kin, anything. So let's see. So what are the possibilities? Kale, case, kit, kip, king, kimono, kilogram. You can have longer words. So there's a whole range of possibilities that could be with the sounds ka and iki. Now you need to listen to the next thing that comes in. Let's say the next thing that comes in is oh. So you hear kill. Now you know the most possible candidate is kill. It can't be kiss, it can't be kip, it can't be king. It could be kill most likely, or it could be killing, yeah, or killer. But anything else to do with the word kill and nothing else. And you don't hear any more after that, then kill, definitely it is. So this is how the listening process goes on. So how does the actual process go on? And there are various theories who looked at how do we do the actual listening. So they talk in terms of, I'm talking about this diagram that I've adapted from Harley 2008. And he talks about how there is the initial contact. So some representation of the sensory input makes initial contact with the lexicon. Okay, so as I said, there is the lexicon which we have set in our brains, and then there is the input that comes and enters our brain through the ears. And all that you have done in Unit 6, where you're talking about speech, actual speech perception. So if you need to refer to that, you can go back and read that module once again, so you will know how this happens, the initial, and you will know more about the speech input. Once that contact has been made, the next stage is that of lexical selection. The sensory here, this is where the system is trying to match the initial input with some representation. It's trying to find the word that the speaker is saying. So here the sensory input, the amount of acoustic input that you hear, keeps accumulating bit by bit. Remember, I said speech is incremental, so it comes in bits, one bit, the next bit, the next bit. As you're getting bits, you can also predict what will follow, because some possibilities are ruled out. So the sensory input continues to accumulate till one lexical entry is selected. So finally the system zeroes in on one thing, like we did with the example with ka, e, and o. And then at that stage is a stage where word recognition takes place. So the listener recognizes the word in the previous example that I gave, kill. So they say, okay, this is the word and nothing else. So the word is recognized, and the recognition, usually, actually, the recognition point for many words occurs long before the actual word is finished. In fact, the context plays a very important role. So if you're saying that the murderer took the knife and went towards the woman sitting on the chair, and his intention was to, even before you hear ki, his intention was to kill, because there's enough in the input to tell you what can follow. It can't be that he went towards the woman to be the king, or you can't put any other word. It has to be kill. And so we recognize the word, and that's when the word recognition takes place. By the way, speech perception does not end with word recognition. The word recognition is one of the key earlier stages. There's a lot, because speech is not just, we don't speak in words, we speak in sentences. And as the module process, as this course processes, you will know more about the context level, higher level, sentence level processing. Here I'm focusing primarily on word recognition, and that's where we stop. Okay. So these are the three basic processes: the initial contact, the lexical selection, and then the word recognition. So let's look at initial contact. What happens in initial contact? There are two kinds of information that can be found in the signal. This is according to McQueen 2007. One is segmental information, that which relates to the features of sounds. These are units smaller than the phoneme, which provide the essential cues needed to identify the sounds in a word. So if you go back to Unit 6, this is where all the acoustic cues are dealt with. And one important one that you will have heard about is voice onset time. And that's a cue that comes in even before the actual phoneme comes in. Now, I will not go into that in detail, the actual acoustic cues, because you will find that information in Module 6. Let's proceed further. So these are one is the segmental information, and the next one is the role of suprasegmental features. This is suprasegmental information. What is suprasegmental? The word suprasegmental means something over and above the phoneme. The phoneme is the sound itself, so pa is a sound. But when I talk about suprasegmentals, I'm talking about something over and above the sound. So, for instance, if I said a word like tailor, so you hear the tay part of the word louder than the part of the word. So what have I done? I have said tay with more stress. Now that is not a sound feature, that is something over and above the sound. So stress is a suprasegmental feature. So listeners process spoken language in ways that are subtly tuned to these phonological structures of their languages. And here we are talking about suprasegmental, or sometimes these are known as prosodic features, sometimes they're also known as rhythmic features. I will be referring to them as rhythm, but they generally overall refer to the same phenomena, things like stress, things like intonation. So a word like come in, you hear the difference between the two intonations. Now that is again a part of the suprasegmental level of language. Okay, so these are overall what I would call prosodic features or rhythm or suprasegmental. I will be referring to them mainly as rhythmic features. So rhythm refers to the regularities which govern the way the elements in the phonological structure of a language are grouped together. All that this definition means is that each language has its own unique patterns. You can recognize a language even if you don't hear the sounds of the word. One thing I would like you to do is listen to any kind of program on television where you have comedians trying to mimic an accent. And they might be speaking nonsense words, but they're mimicking the intonation. And that is very, very important. And you recognize, oh, they're speaking, Chinese or Mandarin, or they're speaking, Hindi with an English accent. So it's the intonation that identifies a language as its unique feature. So each language has its own unique rhythmic patterns, and this plays a very important role in listening. So how is rhythm expressed in languages? Rhythm can be expressed through timing effects. What do I mean by that? I mean the amount of time it takes to say syllables in a sentence. So in most Indian languages, we take the same amount of time to say the syllables. So if, for instance, in a word like, let me give you a contrast with English, because that works very well, because English is a language which it works on stress, where certain bits of the words are stressed and certain bits of the word are not stressed. So for instance, again, going back to the other example that I gave you of tailor, you hear tay louder than That's because I've stressed tay. But if I said that in an Indian language, I'd say tailor, where you hear tay and la are equal, the same amount of time taken to say tay and So languages differ on the amount of time they take to say the syllables. Also factors such as the types of syllables a language has, whether a language has what we call a closed syllable structure. So English, for instance, you can have a word like, you can have a consonant, vowel, and a consonant. That's a basic pattern. So look at a word like cat, k-a-t, cat. Now that's a typical English syllable structure. But you have languages, let's say a lot of languages which do not have a consonant at the end. They do not allow it. Telugu to some extent is one such language which doesn't allow, and Malayalam do not allow a consonant at the end except in certain positions. And there is a big deal of controversy over the syllable structure in Malayalam and Telugu. We will not go into detail about that, but basically it's just to explain to you the syllable structure plays a role. Japanese, for instance, is a language which has a clear CV structure. It does not allow a consonant after in the end position in a syllable. So you have a consonant and a vowel, and that's it. if there is a consonant following, that has to go into the next syllable. So that is the basic syllable structure of Japanese. So these play a very important role in how we listen. So if a language has a CV structure, then they will find it difficult to accept that a consonant, a CVC language. They'll have problems with CVC languages because they do not have CVC in their syllable, the C in the syllable structure, in the word final, in the syllable final position. Then it can also be a function of accent. The accent generally, roughly, refers to the time taken to say stressed syllables as against unstressed syllables. So if you have a language, let's say like English is a very good example, where you have certain syllables in a word are always stressed, and in order to maintain the rhythm of the language, so the time taken between two stressed syllables is nearly always the same. It doesn't matter how many unstressed syllables occur in between. So if you have a lot of unstressed syllables in between, then you tend to swallow them. So let's look at a word, a long word like Birmingham. So what are you hearing? Most you're hearing is B, and you're hearing the hum. But you're in between, you're just not hearing. And if I said that slowly, if I said that without the stress, I would say Birmingham. That's what the word is. It's the name of a city. But because English is a stressed time language, you would say Birmingham. So it depends on which language. It depends on how much stress plays a role in the language. So these factors vary across languages. Each language has its own patterns, and that influences how the speakers listen to the language. In fact, there is a hypothesis that has been proposed by Cutler et al. Beginning in 1983, and the work is still going on, which Cutler refers to as the rhythmic segmentation hypothesis. It's the rhythmic pattern of your language that influences the way you hear. So if your language is a certain rhythmic pattern, that's what you will use in listening to the other language. And you might make mistakes because the other language doesn't have that rhythmic pattern. And so therefore, listeners not only rely on the actual acoustic signal, they also listen for other things. They exploit other sources of information that form part of their language. For example, let's look at phonotactics. So an English listener listening to the words singing star knows that there is a word boundary between singing and st of star. Why? Because English does not allow a word to start with It has to occur only in the word final position. And that's a very good signal. Where you hear in English, you know that's the end of a word. And whatever else is a new word. So this is what we call phonotactics. So English is exploiting. You can also use those kind of phonotactics in listening processes. Linguists have identified three distinct types of rhythmic patterns in languages. One is what they call stress time languages like English and Dutch, where the main rhythmic pattern is maintaining the time taken between two stressed syllables in a sentence. Syllable time languages like Spanish and French, where the time taken it's not to do with stress, it's to do with how much time you take to say the syllables, and it's almost the same. Every syllable you take the same amount of time to say every syllable. Then there's a third category, which is called mora. Now, mora is a very unique phonological category, and it's used mainly in Japanese and in a number of South Indian languages like Telugu, Tamil, Malayalam. We are not very sure how strong the mora is in the languages, but mora plays a role. Mora has really to do with the weight of the syllable. So it depends on how long the syllable is. Is it like a short syllable or is it a long syllable? If it is long, then there is more weight, and if it is short, there isn't that much weight. Okay. Now, psycholinguistic research has shown that similar rhythmic structures encourage similar types of processing in listening. So if you speak a stressed language, then that is going to influence the way you listen to a syllable language or a mora language. And experiments upon experiments have shown that. There's a lot of experiments by Cutler et al. Looking at French, looking at Dutch, and looking at English, Dutch, French, and I think they've looked at Korean. If you look at the module unit, you will find a range of references at the end of the unit which you can use to read on further on. And I can even refer to you to some very important journals like Journal of Psycholinguistics, which will give you lots of information on this topic. There is a lot of research in this area. So some of the tasks that are used in psycholinguistics to study how listening processes occur, and there are many different types of tasks. And one, today I'm going to talk about an experiment that I was involved in looking at word recognition processes in Telugu and Japanese. So before I do that, I'll just give you a brief description of the task that we used in doing this study. It's called Fragment Monitoring or Phoneme Monitoring task, where subjects are told that they have to listen for a certain fragment, so like ta or ba or gi or ga, and they're told that they listen to 5 words, and as soon as they hear the word which starts with that fragment, they have to press a button. So now when they press that button, it depends on how fast they press it, how quickly they press it upon hearing, and how many they miss. So these are the 2 things that we consider when we look at the results. So this is what is known as fragment monitoring. The experiment was to do with Japanese material, because we said Japanese is a Mora time language. The hypothesis, the prediction was that Japanese will use the Mora in the listening to Japanese and to listening to other languages. And in the experiment, they had to listen for 2 targets, ta, a CV target, and tan, a CVC target. So ta in words like tanshi and tanishi, which is CV, 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 or tanshi, CVN, which is n, shi, sh and e, CV, or tan in tanshi and tanishi. So they had to listen for these fragments in words like these and press a button as soon as they heard them. Let's have a quick look at the results. So they found that the Japanese could easily detect ta and tan if the target is exactly 1 mora, because in a word like tanshi has 3 moras, ta, and shi. And in a word like, and it has 2 syllables, tan and shi. But in a word like tanishi, you have 3 syllables, ta, ni, shi, and 3 moras, ta, ni, and shi. Okay, and they had to listen for tan and ta in these 2 words, and they found it very easy to hear ta and tan in tanshi and tanishi, but they had problems listening to tan in tanishi. Why? Because ta is 1 mora, ni is another mora, and shi is a 3rd mora. If you have to listen for tan, where part of the 2nd mora is already in the 1st syllable, then there is confusion. And this is what the results show, and this is what you can find in the visuals, as you can see on the graph. So you can see the number of mistakes for tan in tanishi is very high. It's over 60% missed rates. They couldn't answer that because they couldn't hear it, because it was more than a mora and more than a syllable actually. Now, the same experiment was conducted with Telugu. We tried to see if Telugu listeners, Telugu, which is quite a Mora-based language, would have similar results. And what we found was that Telugu has, listeners showed a very similar pattern to Japanese listeners when they listened to Japanese. They did almost exactly the same thing as the Japanese did. They had problems hearing tan in a word like tanishi because it's more than 1 mora, it's 1.5 mora. Unfortunately, the results for the Telugu study, where the Telugu speakers listened to Telugu materials, were a bit mixed, but they did show a Moraic effect. But the Telugu speakers did exactly the same with Japanese material. What does this tell us about listening processes? Basically, it tells us that our listening processes are influenced very much by the phonological patterns of our language. Even if the effect was not very strong in Telugu, there was a certain effect. And the fact that the Telugu speakers could do exactly as the Japanese speakers did in Japanese tells us that Mora plays a role in Telugu. We need more research in this area in order to find out what the actual rhythmic patterns of Telugu are. So we've looked at initial contact. Now let's look at activation. What happens at the level of activation? Because once there's the initial contact and once this process starts, there is the activation. A whole range of possible candidates are activated. As the information from the speech signal becomes available, all the possible words that can match the input are activated to varying degrees. Some are highly activated, some are not highly activated, some have a medium level of activation. The closer the match, the stronger the activation. And the reason why we have a range of activations, range of words coming up is because, as I said earlier, words contain words within them. So star may turn out to be startle, it may turn out to be start, it may turn out to be starch, it may turn out to be stark. It's only the incoming signal that will resolve this. So as we get closer and closer, more and more input, weaker candidates will fall out and the stronger ones will remain till finally the one that is the actual candidate is identified. So some of the remaining ones that there's a goodness to fit match, and as that fails, then input falls out and the system zeroes in on the best match, and that's what is selected. Word recognition. So we come to the final process. So once the input recognized matches a candidate in the mental lexicon, it's recognized, and all other, it's at that point that other information about that word, it's a grammatical category, it's a noun or a verb, or things like its pragmatic factors, which you will know about more when you will look at sentence level processing further on in the course. All this information becomes available. You get to know more about the word as soon as you know which the word is. Now, lots of psycholinguists have tried to model this and tried to give an explanation for how this happens. And one of the earliest models, here in this course, we're only considering 2 models, and in fact, really we'll be considering in some depth 1 model, but we'll look at one of the earliest models before we go on to the other latest newer model. One is the Cohort Model. It's a very well-known model. It was proposed by Maslin, Wilson, and Tyler in 1980, and it's one of the first models of spoken word recognition. The other important model that we use these days is, and the Cohort model was based on real speech and experiments based on listening processes. The newer model that we're talking about, which is very current and which is considered to be the most explanatory model, is the trace model, early proposed in 1986 by McClelland and Ellman, which has been developed over the years and is one of the first computationally implemented models. It sets to replicate real-life listening processes by simulating the human perceptual processes on a computer. Yet, it is quite successful in predicting how human beings listen. So, we will look at Cohort model very briefly before we look at the trace model. The Cohort model, which I will not deal with in detail, it's all dealt with in detail in the module, is essentially a model that was developed based on a series of experiments on human subjects. And the Cohort model proposes a 3-stage listening process. So, first there's the access stage, followed by a selection stage, and then that is followed by an integration stage. So, at the access stage, for instance, the listeners hear the sound br, and this creates an initial cohort, a whole set of words with br in the onset. So you have brand, bran, break, brow, brown, and brain, some of the words. This is an example. And once this cohort of words is activated, then you have the selection stage. Now, the listeners Here further on after br, they hear a, and this causes all the words that do not have a to drop out of the cohort. And there are only two words left, that is break and brain. And when k appears in the signal, then brain, which doesn't have the sound k, is dropped out, and this leaves only one candidate, break, which matches the input completely. Now, then comes the integration stage. This is the third stage where all the knowledge, all the information about the words at that point integrates the word into the sentence. Now, this is a more, cohort model is quite a linear model because the three stages don't interact with each other. So, if there is any mismatch at the stage of the integration stage, by the time you recognize a word as break, but it doesn't actually match with the rest of the sentence, then it's too late because the word has been recognized, so, and it's the wrong word, so the system has to go back and process all over again. But cohort model is a very useful model. It has given us a lot of information about human listening processes. But following on that, we have the trace model, which is much more explanatory and much more powerful in the way it tries to explain and replicate human listening processes. So I'm going to talk a bit about the trace model more in detail, though you have all the information available in the course notes. The trace model keeps the three-stage approach that the cohort model and all previous models had in trying to account for human listening in spoken word recognition. But it's the most important aspect of the trace model is that it's highly interactive. And all the levels interact with each other, so that information is, it's a much more efficient model in that. So mismatches, it gets rid of mismatches earlier in the listening processes, unlike the cohort model, which you have to wait, which comes right to the end before you realize that there is a mismatch. So in that sense, the trace model is a bit more powerful. And the trace model is what we call a connectionist model. It's an interactive model where all the levels connect to each other. The trace has three interconnected levels of perception. One is what we call the feature level. So if you have a sound like per, so it has the features voiceless and it's bilabial, it's a stop or an obstruent. So these are its features. And then at a high level, it's at a phoneme level, and where the features all bundled together to form the sound phoneme per. And then at a high level, a word level, where you can have words with per in word initial, medial, or final positions in the word. So, and there is a competition between the units at each of these levels. And at the same, if you look at the diagram, which will come up on the screen, you will see that there's at each level there's facilitation. So some words are facilitated and they are more activated. Some are stopped from being activated. There's inhibition because they do not match with the input. So there's both happening at the same time at each level. And each level, if there's a mismatch at the word level, or if there's some specific information at the word level, that is fed back down to the feature level. So there's bottom up and top down. What does this mean? This is clear indication that as we listen, we do not listen sound by sound, construct the word, then word by word, and then construct sentence by sentence. We do not listen like that, because all information interacts with other information at every minute, every millisecond. As the signal is received by our system, we are integrating information from various levels. And the trace model tells us specifically at the word recognition level, what types of interaction happens and which are the levels. So there's the feature level, the phoneme level, and the word level. And this is quite a powerful model because it inhibits, it gets rid of mismatches earlier on. You don't have to wait till to the end before a mismatch is recognized, and then that has to be thrown out and a new match has to be found. And that is its power. The trace model is a computational model, as I said earlier. It tries to simulate human listening, but it has been proven to be quite a successful model. So this is the current model that psycholinguists are using to explain listening processes in human beings. So this is basically, we have looked at two important models of spoken word recognition in speech perception. So briefly to summarize what I have said so far, listeners appear to work out where words are in spoken utterances. So they recognize words by using the information in the speech signal, which specifies the location of the boundaries, where a word begins, where a word ends. They also use phonological knowledge, like I remember I talked about the phonotactics. You can go back and listen to my talk again to hear about how phonotactics plays a role in listening. And they use this knowledge to, in the process of identifying the boundaries, the borders of words, and listening relies on a process of competitive evaluation of many words and trying to find the word that is represented in the mental lexicon to the matching that with the incoming signal or speech input in order to recognize words as they are. And then after this, the rest of the processing goes on. So speech perception does not end with word recognition. It goes on further up. In this module, we have just focused on one level, or rather one stage in the process of speech perception. Thank you very much.